Good morning, everyone. Thank you for listening to all the five lectures so far. We have completed moment of inertia. I hope you have understood how to find out the moment of inertia of an object. In today's class, I want to teach you something new. I want to teach you about torque. Okay. The torque is the rotational effect of a force. Like, for example, you're trying to open a nut bolt with a spanner, or you're trying to open a door, or you're trying to open the cap of a bottle, or you're trying to twist something like a doorknob. All of these things, wherever you're trying to twist something, you're applying torque. Okay. So today's class is about torque, the rotational effect of a force. So first of all, what is torque? Torque is the rotational effect of a force. Torque is the rotational effect of a force. So what are the examples of torque? When you walk up to a door and when you are pushing the door open, then in that case, the door is attached to a frame. Okay, so this is your door. That is your door knob. It's a little bit open. And this entire door is attached to a frame. This entire door is attached to a frame. So this is the axis of rotation of the door where the hinges of the door are connected. So when you go up to the door and when you apply a force to this door, whether to open it or to close it, the entire door is rotating about this axis. Now keep in mind what a force can do. A force can move something, right? It can shift something, it can stop something. A force can cause some kind of motion. So if this door was not attached and you push the door, what would happen? The entire door would go forward. That is the effect of a force. If just the force was acting, then the entire door would go forward. So if you look at it from the top side and only a force was acting, if this is your door and only a force is acting on this door, then after some time, this door is going to go forward and it is going to end up over here. The entire door is going to shift. That is the effect of a force. But when you take the exact same thing, when you take the door, but you connect it to an axis at one end. So this is the symbol for an axis when you are looking at it from the top side. I don't think it's so clear, so I'll show it to you once again. The symbol for an axis is like a circle with a cross or a dot, doesn't matter. So that's an axis. So when you apply a force to such a thing from one end, so basically this door is going to swing open. So there is a difference. We have studied this difference from the first day itself, that something is rotating. Different parts of the object are moving differently. This is your axis of rotation. So torque is the rotational effect of a force. When you're applying a force on an object and the object is rotating, the rotational effect of that force is called as torque. So wherever you have torque, you will have two things common. First of all, wherever you're applying the force, there will be a point of action. Okay? That point is called as the point of action of the force. The point of action is important. So there is a point of action of the force. And in addition to the point of action, there is a line of action of this force. So in addition to the point of action, there is a line of action. दो चीजें, there is a point of action and there is a line of action. And there is this axis. So there is a distance from the axis to the line of action. This distance is perpendicular to both the axis as well as to the line of action. So we'll talk about this a lot when we solve problems. So like I told you, torque depends on two things. So torque depends on, the symbol of torque is tau. This symbol is called as tau. So torque depends on R. It also depends on F. In fact, if you write the perpendicular distance from the axis to the line of action, then you can write torque is equal to Rf, where R is the perpendicular distance from the axis to the line of action. Okay? So this is the mathematical definition of torque. Do you understand what torque is? Torque is the rotational effect. When you push something and it rotates. To try this out right now, take your pen, put it on your table, right? And try to push on the middle of the pen, the midpoint of the pen. So if you try to push the midpoint of the pen is just going to roll ahead. Okay, try it right now. And if you try to put the pen down and you push on the edge of the pen, then the pen is going to move forward and also rotate. both at the same time. It's going to rotate more because the friction on the table is like a lot, but it is going to move forward and it is also going to rotate. You are doing the same thing. You are pushing the pen. So what you can do is you can apply a force. You cannot apply a torque. You can apply a force. Depending upon the point of action, depending upon the line of action, the pen will rotate. So if you are thinking that I apply a force on the edge of the pen will always rotate. No. Apply the force on the edge, but apply it along the pen. Like, apply it on the tip of the pen, apply it on the edge of the pen, along the pen. In such a case, the pen is not going to rotate. The pen is going to get pushed forward. So not only does the point of action matter, the line of action also matters. Okay, dhyan rakho. So torque depends on two things. It depends on R and it depends on F. The majority of this chapter is about calculating torque and finding out what is called as angular acceleration. So you must have studied about angular acceleration in circular motion. So we'll come to angular acceleration when it is required. Today's class is all about torque and calculating it in a few different situations. So, because I defined torque to you, let's give you an example and let's show you how torque is calculated. Let us say we have a nut bolt. ठीक है, अपने पास एक nut है. We have a nut, and this nut I'm trying to open with a spanner. So I hope this kind of a diagram is very convincing to you. So I hope there is a nut like this, and it's convincing as a nut. And then I try to open this nut by a spanner. So I get a spanner, I connect a spanner, like I put a spanner on this edge of the nut, and then by pushing on the spanner, I try to open this nut. So this nut is going to start rotating and the nut is going to open. So what is the axis of rotation? In this case, the axis of rotation passes through the center of the nut and it goes down like this. The nut is rotating. This is your axis of rotation. What is the line of action of my force? If I'm applying a force over here and the force is getting applied like this, like the way I've showed it to you, I showed a curved arrow because everything is rotating. But if the force is getting applied like this, then this is your line of action. This thing is your line of action. Now convince yourself that whenever there are two lines, you can draw a third line that is like perpendicular to both of them. You can. And let's say the length of that line is equal to r. So over here, in this case, r is perpendicular to the axis. R is also perpendicular to the force. If you want to prove this thing to yourself, on the table, put a pen, put another pen, but vertically nearby. Now find out the shortest distance between these two pens. So that is the perpendicular distance. Okay. So in school, you must have studied something like this, perpendicular distance between two lines. So there is one axis, there is another line of action, and you can find out the perpendicular distance between them, that is r. So you can now write torque is equal to r into F. So let's show you how it works. Let us say that the value of r is equal to around 10 centimeters, which is the usual length of a spanner. And to open something, you're applying a force of 25 newtons. Direct example. So what is the value of torque? So always remember to write R in SI units. So 10 divided by 100 meters, and force is equal to 25 Newton. So force is equal to 25 Newton. So the product of this is 2.5. What is Newton into meter? You have studied work per energy, you would say joule, but torque is not work. Torque is the effect of a force. So we write Newton meter. The unit of torque is Newton meter. Okay. So when you go and look at auto, like, motorcycles and all, when you look at a, I don't know, Hero Honda, or you look at a KTM, or you look at some kind of a bike that you're interested in, you will go and see, they'll give you some engine power, like, 146 bhp, and they'll give you the engine torque. It's equal to 193 Nm. So that is Newton meter. Okay. Torque is Newton meter, not joules. Keep in mind the SI unit of torque is Newton meter. Okay. So this is a very simple example of how to calculate torque. Try another example. Let us say that there is the shutter of a shop. Okay. The shops, they have shutters. So inside the shutter, there is a wheel. There is a round wheel. And somebody is pulling down on this wheel to close the shop. They're trying to shut the shutter and go away. So let us say the radius of this wheel is equal to 7 centimeters. And this person is applying a force of, let's say, 35 newtons. Can you calculate what is the torque? Pause the video, give it a try. Try to draw the axis of rotation, try to draw the point of action, try to draw the line of action, and also try to calculate the torque. You are learning to try to do all these things. Karo. I hope you're done. Okay. So first of all, this is your axis of rotation. The axle of the shutter is like, which is parallel to the shop wall. It is the axis of rotation. The entire shutter is rotating about this axis. Secondly, this point where the force is acting, this point where the force is acting through whatever medium, rope or the shutter, that is your point of action. What is the line of action? The line of action is passing through this line. So that's your line of action. What is the distance that we want? This one is the distance that we want. It's perpendicular to the line. It is also perpendicular to the axis. It is perpendicular to two things at the same time. Okay. So torque is equal to R into F. Tau is equal to R into F. So torque is equal to R, which is equal to 7 centimeters. Convert it into meters by dividing it with 100. So torque will become 7 meter divided by 100. So it is 7 by 100 meters. Multiplied by force, which is equal to 35 Newton. So 7 5s are 35, 7 3s are 21, plus 3 is 24. 245 by 100. So 2.45 Newton meter. That is the torque. So what's the first lesson? Torque is the effect of a force. What does it depend on? It depends upon how far you're applying the force from the axis. Distance from the axis of rotation. So let's summarize that once again. Torque depends on two things. It depends on R, which is the perpendicular distance from the axis of rotation. Perpendicular distance from the axis of rotation to the line of action. And then it also depends upon the force. Okay? It depends upon the force that you're applying. Torque is the rotational effect of a force. Let's try some more examples. Let us say we have the same exact shutter, 7 centimeters. I'm not drawing the shell, only this is 7 centimeters. And somebody is pulling on the shutter, not vertically, but like this. Okay, so somebody is pulling on the shutter in this direction. Same question. This is 35 newtons. Let us say this angle is equal to 60 degrees. What is the torque of this force? What is the torque of this force? So initially, first of all, you will draw the axis of rotation. That is your axis of rotation. Next, you will draw the point of action. Then you will draw the line of action. So this is your line of action. Now, what is the perpendicular distance between the line of action? If you notice, this distance might be perpendicular, but this angle is not 90 degrees. This angle is equal to 60 degrees. So you cannot say that this is the perpendicular distance. The perpendicular distance is not 7. The perpendicular distance is something other than 7. So let's focus on that part first. If you enlarge the shutter a little bit, this size, this is your axis of rotation, this is your point of action, and your line of action is going like this, where this angle is equal to 60 degrees. If you draw a perpendicular, then you will get a right angle triangle where this angle is equal to 60 degrees. This is your 7 centimeters. This is your R. The perpendicular distance from the axis, I told you it can be a dot or it can be a cross, to the line of action. So this is your R. It has to be perpendicular to both the lines. If you still cannot understand it, you have two hands. Take one hand here, put another hand, cross on top of it. The distance between the two hands is your perpendicular distance. Okay, got it? So if you tilt one hand, that distance is going to change. But you can easily imagine that you can draw a line between two of your hands if they are placed on top of each other, so that the line is perpendicular to both of your hands. You can do it. Give it a try. Okay. So you want to find out R. So how do you find out R? Clearly, if you write sine 60 degrees, then sine 60 degrees is equal to R divided by 7. Or R is equal to 7 sine 60. Done. What is your force? 35. So you can write torque is equal to R into F. So R is how much? 7 centimeters into sine 60 into 35. So this is 2.45 root 3 Newton meter. Did you see how we found out the perpendicular distance from the axis of rotation? So torque depends upon perpendicular distance and the force. Okay. At this point, there is another way of solving this exact same problem. The same problem, but there is another way. So right now, if you want to, you can pause it, go back a little bit and see how I found out the perpendicular distance. You can try this once again on your copy. And then once you're perfect with it, let's see the other way of solving this. Okay, you'll get the same answer. So what's the other way? The other way is, instead of dealing with trigonometry with R, what we do is we find out the component of F. Okay? We find out the component of force that is causing the rotation. In this case, we found out the perpendicular distance, we required trigonometry. There also will require trigonometry, but we can understand a little bit of how this thing is working. So if you notice, this force has two components, one like this and one like this. Whenever you're pulling on something at an angle, so obviously there are two components. If you're pulling in it like straight, then there is only one component. There are not two components. But if you're pulling at it on some angle, so there will be two components. This case, there is a component like 35 cos 60, and there is a component that is 35 sin 60. Now you think about it yourself. Which of these components is causing a rotation? If you pull along 35 cos 60, then you will basically drag this thing forward. This thing is going to basically drag it forward. It's going to drag the entire shutter out of the wall. Not possible. But that is the effect of the force. But 35 sine 60 might drag it, but it is actually trying to rotate that shutter. Imagine it in your head. This force is actually trying to rotate the shutter. That force is trying to pull the shutter out of the wall. What do we want to do? We want to calculate the rotational effect of the force, not the dragging effect. So the second method to do this is to first of all find out the component of the component of the force perpendicular to R. So what is R right now? R is the distance from the axis to the point of action, where R is the distance from the axis to the point of action, not the perpendicular distance anymore. So you're trying to find out perpendicular for force. So don't deal with R. R is simply the distance from the axis to the point of action. Okay, these are two separate methods. They'll give you the same answer. So you can choose whichever you like. In a situation, one of these two methods will be easier. And maybe both will be easier for you. It's up to you. So component of force perpendicular to R. So what is R? R is exactly what's given to us. R is 7 centimeters. It is the distance from the axis to the point of action. We are no longer interested in the line of action of this force. So we are not going to deal with line of action. Instead of line of action, we are going to deal with components. So what is the component of this force that is perpendicular? So I'll be choosing the perpendicular component, which is 35 sine 60. So F perpendicular to R is equal to 35 sine 60. What is my value of R? My value of R is 7 centimeters. Now you can directly apply torque is equal to R into F perpendicular. Direct. So you can write 7 centimeters multiplied by 35 times sine 60. So your answer is still going to be the same, which is 2.45 root 3 divided by 100. Wait a second. In the previous case as well, when we took sine 60, I think I forgot to multiply the divided by 2. So 1 second, I made a mistake over there. When I was calculating, I said R is equal to, the previous method. Look to the left of your screen. I said R is equal to 7 sine 60, right? We calculated R is equal to 7 sine 60. And then I said torque is equal to R into F. So when I did this calculation, 7 by 100 sine 60 is equal to root 3 by 2, and the force is equal to 35. I think what I did is I just wrote 2.45 root 3. So it's 2.45 root 3 by 2 because there's a 2 in the denominator. I'm sorry, I made a small mistake. Okay. So here also you'll get the same answer, 2.45. 7 into 35 is 245 by 100, 2.45 root 3 divided by 2. Okay, the same answer. So whichever method you follow, your answer is going to be the same. Either you take the perpendicular distance from the axis to the line of action and you take the entire force. That is one method. You take the perpendicular distance from the axis to the line of action and you take the full value of the force. Okay. or you take the distance from the axis to the point of action, which is just r, and then you take the component of the force that is causing rotation. So it's up to you. You take a component of r or you take a component of f, one and the same thing. One thing you must have noticed is that we get a sine function here. So that brings me to the actual definition of torque. Torque is a vector quantity. So torque is a vector quantity. R, the position vector, is also a vector quantity. R is also a vector. Force is also a vector. And we have the sine function relating both of it. So which is a very good reason to believe that torque is the cross product. It is the cross product of R with F. Okay? So torque is the cross product between R and F. So this gives us a very proper understanding of the vector nature of torque. So I'll draw the same figure once again, the shutter figure, but slightly in 3D. Imagine that this is your shutter and the axis of rotation is vertically upwards. The axis of rotation is vertically upwards. Now this is your R vector. From the axis to the edge, the point where the line is, like, where the force is acting, to the point of action. That is your R vector. So when you're trying to find out the perpendicular distance, you are trying to find out a component of R. That's what I said. You either find out the component of R or you find out the component of F, one and the same thing. Then you apply a force over here. So you are applying a force in some direction over here. This is your force. So if you extend the force to both sides, you will get your line of action. So my two methods are, you either take the perpendicular distance to the force or you find out the perpendicular component of the force. The choice is up to you. Both of them, they suggest that torque is equal to R cross F. So how does R cross F look like? This is your R vector. That is your F vector. Now you might remember something that is called as the right hand thumb rule. Right hand thumb rule. You might remember this. So you can point your fingers along R and you can move your fingers towards F. You will notice that the thumb of your hand is pointed upwards. The direction in which your thumb is pointing is upwards. So whenever a torque is acting, the torque is always parallel to the axis of rotation. Torque is parallel to axis of rotation. It is because of this that the object is rotating. समझ में आया? Or you can say that whenever a torque is rotating and whenever a torque is acting, the object starts rotating along that direction. So that it makes the torque direction the axis of rotation and the object starts rotating. For example, there is a football kept on the ground. Okay. If you've played with the football, you'll get some idea. You go and kick the football right on the center. The football is not going to spin. But if you kick the football on the edge of it, towards the edge, the football is going to start spinning. So how does the football know what is the axis of rotation? Football doesn't know. So when you're keeping the football on the ground and when you go and kick the football at one edge, automatically there is a distance and the torque starts acting. The direction of the torque becomes the axis of rotation of the football. Okay. So this is the idea of torque. In today's class, we'll try to do a few different questions about torque. The effect of torque is to rotate something, but also if there is more than one torque acting, an object can stay at rest, just like forces. So let's talk about all the different places where torque can act. Let's solve a few different questions. Before that, just keep this understanding in mind that torque causes rotation. The effect of a torque is to cause rotation. But if there are a few different torques acting on a body, then all the torques can cancel out. And if all the torques cancel out, in such a case, even if so many torques are acting, the object is going to be in equilibrium. Such kind of an equilibrium is called as rotational equilibrium or static equilibrium. Okay? Rotational static equilibrium. If there are many different torques acting on an object, the object might be in equilibrium. It may not rotate or it might continue rotating at the same speed. Okay, so let's deal with a few questions, few simple questions on torque. Let's start with the first same basic question that we have studied so far. Let's give you the same question once again. Try to understand how these figures are drawn, because you will deal with these figures in your books. So try to understand how these figures are drawn. What I've drawn right now is what is called as a pivot, also known as an axis. It is a point that cannot move. So this is an axis. A rod is attached to this axis. Okay. And this rod is allowed to fall. A rod is attached to this axis and the rod is allowed to fall. So in the situation that's given right now, you might have studied a little bit about center of mass. So the weight of this rod is acting at the center of mass. So the weight of this rod is acting at the midpoint of the rod. You have studied about this. If you have a uniform rod, the weight of the rod is going to act at the midpoint of the rod. So it's going to act over there. So let us say the length of the rod is equal to L. The length of this rod is equal to L. I'm asking you a very simple question. If the rod is 2 kgs and its length is 45 centimeters, what is the torque of the weight? What is the torque of the weight about the pivot right now? About the pivot point in the situation shown right now. Right now. Do it. It's a simple question. Do it. Pause the video, give the question a try. First of all, the first thing you should do in a question like this is you should draw the axis of rotation, or at least you should be aware what is the axis of rotation. This is my axis of rotation. Now you choose one of two things in your head. Do you want to apply torque is equal to R cross F? Or do you want to go through the component way? So if you want to apply torque is equal to R cross F, you first of all draw what is R. This is your R. You draw what is F. That is your F. Okay. If you want, you can write R and F in vector form. So you can write that in this case, my value of R is equal to 45 centimeters, 45 by 100, but it is pointing along the positive x-axis. So this direction is given as I cap. So my R is 45 by 100 I cap. My force is equal to mg. That is 2 kgs, which is 20 newtons, but it is acting in the downward direction, which is the minus j direction. So this is minus j cap. So minus 20 j cap. And now you can calculate torque is equal to R cross F. Torque vector is equal to R cross F. So R cross F, which is 45 by 100, I cap multiplied by minus 20 j cap. So it is I cap cross j cap. You might remember I cross j is equal to k. You might have known this way of calculating cross products. So this right side term is k cap. What about the left side term? The 45 into 2 is 90. That's minus 900. So you will get minus 9 k cap. So what is minus 9 k cap? What is k cap first of all? So if you have I, try this first of all. This is your right hand thumb rule. This is I. This is minus I. This is j and that's minus j. So what is the direction of k? To find out the direction of k, what you do is you do I cross j. Okay, you calculate I cross j using your right hand thumb rule. So if you're doing this right now by watching the video, then k is going to point upwards towards you. You do your you put your finger on the screen and you curl your fingers, then the thumb is going to point towards you. So minus k is into the plane of the screen. Okay, it is inside the screen, towards the inside. If you tap the screen, that is the direction of minus k. So how is the torque acting? The torque is acting towards the inside of the screen. That's minus 9. ठीक है, समझ में आया? Minus 9 k cap. Or you can say 9 minus k cap. Same thing. So the value of torque is 9. The direction is minus k. You can also do the same thing. Exactly like I explained, you can do the same thing just by using the components also. Here you don't need to apply components because R is already the perpendicular distance. So you can directly say torque is equal to 2 kgs ka force, which is equal to 20 newtons multiplied by 45 centimeters. So 45 divided by 100. Automatically you get the value of 9. But you won't get any directions. Okay, you will not get any directions. So you will have to imagine how the rotation is happening. इतना समझ में I think तुम्हें आ गया होगा. At this point, because I showed you what a torque with a negative sign means, let me also show you how the signs are interpreted. Whenever something is rotating, If you place your fingers along the direction of rotation, if you place your fingers along the direction of rotation, your thumb gives you the positive direction. Understand this. Your thumb gives you the direction of this rotation vector. You might have known about omega, the angular velocity. Okay. So that is what I'm talking about. So whenever something is rotating and you place your fingers along the direction of rotation, then your thumb gives you the omega vector or the rotation vector. Or if something is accelerating, the acceleration vector. Okay. So understand that. So if something is rotating, like in the last case, our rod was rotating. So in this case, if you try to place your fingers like this, if you try to do it on the screen, then automatically your thumb is going to point inside the screen, which is also how our torque was going. Our torque was going in the negative k direction, -9, inside. So this is the idea. When something is rotating, place your fingers along the direction of rotation. You will get the thumb is going to give you the rotation vector, whether it is of acceleration or it is of angular velocity or even of angular displacement. Your thumb is going to give you the vector. Fine. Let's try another one. So let's give you a question on rotational equilibrium also. First of all, we are going to do rotational equilibrium. We'll do acceleration problems later. Rotational equilibrium problems first. Let us say that there is a plank that's kept between two supports. So this is a support, it's a fulcrum, it's a support. There is another wedge over here, that's a support. And there is a plank that is kept on them. So there is a plank that's kept like this. The plank is massless, there is no weight of the plank. Okay, the plank is very thin, it's kept on two supports. In between the supports, somewhere, a very heavy mass is kept. Over here, a very heavy mass is kept. The mass is around 10 kgs. The distance of this mass from one of the supports is 5 centimeters. The distance from the other support is 15 centimeters. And a mass is kept between the two supports. The question is to find out what is the normal force acting on these supports. What is the value of N1 and what is the value of N2? So however you think about this, first of all, you understand that N1 plus N2 is balancing the weight of this mass. So the mass is going to have a weight in the downward direction around 100 newtons. So N1 plus N2 is balancing the force of 100 newtons. That is why the mass is at rest. The mass is at rest. The mass cannot fall down because the plank is kept on two supports. The mass cannot fall down. The mass is at rest. So it is at rest because N1 plus N2 is supporting 100 newtons. Now you think of two extreme cases. Before we start solving the problem, you think of two extreme cases. What if the support was exactly the same, but the mass was kept exactly on top of one of it, like this one? So we would not require this support at all. We actually do not even require the plank. The mass can somehow be balanced on that support. It might fall down, but it will get balanced on that support itself. In exactly the same way, if you try, then you can remove the mass from that support and you can bring it and you can keep it on this support. Again, same thing. The other support is no longer required. So N1 is equal to full weight and N2 is equal to 0. The one thing we understand from this kind of a thought experiment is that the value of N1 and N2 are not equal. N1 is not equal to N2. In fact, N1 or N2 can be 0 also. It basically depends upon this distance. So how can we talk about the distance and a force? So whenever you're going to talk about a distance and you're talking about a force, one of the obvious ways to think about is work done. But here nothing is moving. So here what you have to think about is torque. The question is about which axis. There are many different points you can choose as an axis. What I suggest to you is that you choose a point that is at rest. So either you choose this support, okay, here every point is at rest. You can either choose this support, you can choose that support, or you can even choose the center of mass of this block. If you choose a point where a force is acting, if you choose a point where a force is acting, automatically the torque of that force is going to become 0. The torque of that force is going to become 0. So at least one term in your equation is going to be 0. Kaise? Because if you choose a point exactly where a force is acting, what is the distance to the point of action of the force? Zero. The value of r is zero. So because r is zero, the torque is automatically zero. So you always choose a point where a force is acting, and preferably the point should be at rest. Okay. So once you have done that, what I'm going to do is I'm going to choose this point, this left side point. You can choose whatever point you want. I'm choosing the left side point, and I'm going to find out torques. Next thing, when I'm going to find out torques, notice that this 100 Newton force wants to take the entire thing down. It wants to, it cannot, but it wants to take the entire thing down. And the N2 force is struggling hard to support it, and it's going to apply a torque in the reverse direction. So next thing is you choose some direction as positive. Normally people take anti-clockwise as positive, but you are free to choose clockwise positive, anti-clockwise positive. You choose some direction as positive. So first thing what you do, you find out a point where you can take as the axis. Once you choose an axis, it is fixed for the entire problem. Next thing, you choose a positive direction of rotation. Okay, you choose a positive direction of rotation. You choose a positive direction of rotation. So here I've shown you my positive direction. That is my positive direction. I'll change the color if you want to, like, highlight that thing. So my positive direction of rotation is this one. Okay. Now we will start writing the equations. So what is the distance of N2 from the axis? 20 centimeters. Is the distance perpendicular? Yes, it looks perpendicular to me. So the torque of N2 is equal to plus, because it's acting in my positive direction. The value of the distance is equal to 20 centimeters, and the value of N2 is N2. How about the torque of weight? The torque of weight is negative. The distance is equal to 15 centimeters. As you can see, the distance from the axis to this point is equal to 15 centimeters, the perpendicular distance, okay? Not this distance, not the distance to that thing. So that is not perpendicular. I'm taking the perpendicular distance, 90-degree distance. That's 15 centimeters. And the force is equal to 100 newtons. So this is my total torque. Because it is not rotating, that's your third point. Tau is equal to 0 because the object is in equilibrium. So this gives you an equation. Luckily, in this equation, there is one unknown. There could be two unknowns also. So in this equation, there is one unknown. So you can directly solve and find out the value of N2. So what you can do is you can say that 20 N2 is equal to 15 into 100. I cancelled the 100 already. Okay. So you can say that N2 is equal to, I think, 75 newtons. So when N2 is equal to 75, then automatically the value of N1 becomes 25. Okay. So N2 is 75, N1 is 25. I've solved my problem. It looks like N2 is equal to 3 times N1. N2 is equal to 3 times N1. It looks like it, at least from the solution that we have, it looks like N2 is equal to 3 times N1. Can you prove it? Try karo. Pause the video right now, give it a try. Can you prove that N2 is equal to 3 times N1 without solving it like this? So you pause it, you try it. I'll show you how to do it here. The thing is, you don't write the equation about that axis. I told you, you can choose any axis you want. Whatever axis you choose, your answers are going to be the same. The equation, the workout is going to be different. So depending upon the axis you choose, your workout is going to differ, but the end result is going to be the same. So let me choose this point as the axis. This is my axis. So if I choose that point as the axis, first of all, the torque of which force becomes zero? In the previous problem, the torque of N1 was zero because N1 was acting right at the axis. So if you go and push a door right at the hinge, the door is not going to open. You can push with all your might. You can actually call 4 of your friends and push on the hinge of the door is not going to shift. If you push on the frame of the door is not at all going to shift, no matter how much force you apply. Maybe the frame will fall out of the wall, but the door is not going to shift because the torque of that thing is going to be zero. Okay. So in the previous case, N1 was equal to 0. The value of N1 over here was equal, like the torque of N1 was 0. Here the torque of the weight is going to be 0. Now, what is N2 going to do? N2 is trying to rotate it upwards. If you look at N1, N1 cannot, but it is trying to rotate the entire thing upwards also. So understand that this upward rotation and that upward rotation, they are in opposite directions. The N2 is going to go towards the left and N1 is going to go towards the right. So this thing is actually clockwise and that thing is actually anti-clockwise. So in this problem, we have chosen that direction as positive. So the torque of N1 automatically becomes negative. Now you write the equation. So what you will write is plus, for N2 it is plus. The distance is equal to 5 centimeters. You see the distance changed because the axis changed, the distance also changed. So distance is 5. In this problem, this is what happens. यही होता है. तुम axis को change करोगे तो distance from the axis automatically change हो जाएगा. ध्यान रखो इस चीज का. So that is 5 multiplied by N2, and then if you take the find out, like if you find out the torque for N1, then that is minus, and you have 15 divided by 100. Minus because I told you anti-clockwise is positive, clockwise is negative. So this direction is going to be negative. Ulta direction hai. Minus 15 divided by 100 into N1 is equal to 0. Why 0? Because the system is in equilibrium. Okay? Three-step process. The system is in equilibrium, torque is equal to 0. Axis निकालो, direction of rotation निकालो, और फिर उसके बाद torque को 0 कर दो. Now you solve it. You cancel these and you will see that 5N2 is equal to 15N1. So automatically N2 is equal to 3N1, which is what I wanted you to prove. So it's proved. Okay. Samajh Maya, this is how you deal with torque. This is how you deal with torque in different situations. I'll give you another example. You can try that one as well. Let us say that there is a ladder resting on a wall. Okay, you can imagine this very easily. There is a ladder that is resting on a wall. This is your ladder and it is resting on a wall. So this ladder is going to have some of its weight, mg. And let us say this angle over here is equal to 60 degrees. I'm asking you the very simple question of finding out what is the value of N1 and what is the value of N2. It is very obvious that without friction, the ladder is going to slip. So just imagine that at this point, the ladder is actually fixed to the wall or there is a stone kept over there. It is not letting the ladder slip. The ladder is in equilibrium. Somehow it is in equilibrium. The weight is equal to mg. That is equal to N2. This is equal to N1. And let us say the length of the ladder is equal to 2 meters. So find the value of N2 and N1. Find N2 and N1. So if you're doing this question, like, you can pause the video right now. You can try it on your own, think about it, and then you can come back. Okay, now you try, I'll try it with you. Let's say this is your axis. Let us say this is your axis. When I said you can take the axis as a point where the force is acting, an even cleverer thing to do is to take it at a point where an unknown force is acting. So not only are you eliminating a force, you're also eliminating an unknown force. So you're actually solving the problem. So you take the axis at a point where an unknown force is acting. So let us say this is the axis. Now you want to find out perpendicular distance. So this problem will also give you a very good idea of how to find out perpendicular distance. See, this is your perpendicular distance to the weight. If you take N2, then the line of action of N2 is like this, and the perpendicular distance is this one. This is your perpendicular distance. Samajh mein aaya? So for your weight, the perpendicular distance is horizontal, and for your N2, the perpendicular distance is vertical. Because N2 is horizontal, the perpendicular distance is vertical. अगर तुम्हारा force vertical है, the perpendicular distance is horizontal. Simple common sense. Now, what is this distance? The weight is always going to act at the midpoint of the rod. So this distance is 1 meter. So if that distance is 1 meter, this is 1 cos 60 degrees. Now that is 2 meters. So this distance is equal to 2 sine 60 degrees. So this distance is also equal to 2 sine 60. Konsa? This distance is 2 sine 60. Now you write down the equation. What is N2 wanting to do? N2 wants to rotate the ladder like this. What does mg want to do? It wants to rotate the ladder like this. Just imagine, right? You take some direction as positive. Since I took anti-clockwise as positive, now I'm going to take clockwise as positive and show you it doesn't matter. You just choose whatever you like and stick with it. Jo bhi tum karo, it's very important to stick with it throughout the problem. once you choose the axis of rotation, once you choose the direction of rotation, do not change these things in the problem. ठीक है? तो अब कितना आएगा? तो you will get plus, for the weight you will get mg. So what is the weight of my ladder? Let's say the weight of the ladder is equal to mg only. So plus mg multiplied by 1 cos 60. ठीक है? तो plus mg multiplied by 1 cos 60. And for n2 you get minus sign because it's rotating in the opposite direction, and you will get minus n2 into 2 sine 60. What do? We say it is equal to 0. Why? Because the system is in equilibrium. Three-step process. Always follow the three-step process. Find an axis, choose a choose a direction of rotation, and then you say the equation is equal to 0 because the system is in equilibrium. Now you can solve and find out n2. Like I said, you're actually solving the problem by taking it at that point. So you can say mg into cos 60 is equal to n2 into 2 sine 60. So basically n2 is equal to mg divided by 2 tan 60. Tan 60 is equal to root 3. So n2 is equal to mg by 2 root 3. समझ में आया? Simple. ठीक है? Now how about n1? You can also find out n1 in exactly the same way that you found out n2. Or you could say that n1 minus mg is equal to 0. Okay? N1 is acting in the upward direction, mg is acting in the downward direction. So you could say that n1 minus mg is equal to 0, and you could solve it. So this is how you solve the problem. This is how you find out the value of n2. There is no need to find out n1 because n1 can be found out directly. Just find out the value of n2. n2 is equal to mg divided by 2 root 3. So when you're solving questions, you'll find out many instances of the ladder problem. You'll find out many instances of this kind of a problem. One way that problem is asked is that, like, let's say there are two people who are walking on a road and they are carrying a very heavy log. Okay. And on this log, let's say a very heavy mass is hanging. Like, let's say 100 kg block is hanging. So you can find out which person is sharing how much weight. So these questions can be asked in several different ways. In mains, usually when you get these questions, the questions are like simple formula based. In advanced, you'll have to think about the question a little bit to solve it. But otherwise, always keep in mind, right now you don't require an integration. So to those of you who did not understand integration very well, no problem, forget about it. This is another part of the chapter where you can just directly start solving. I hope you understood the lecture. Let me know what you did not understand, and let's see you again in the next one. Okay, goodbye people.